Hi, I'm Amy Heather from the University of Exeter, and I'm going to describe our work into improving the reproducibility of healthcare simulation models as part of the STARS project. Our focus in this project was on discrete event simulation models, which are computer models of a system over time, like patients arriving and waiting for treatment in a clinic, for example. And we can use these models to help understand and test a system under different scenarios. We're interested in the reproducibility of models like this that have been shared. So reproducibility is about whether it's possible to regenerate the reported tables, figures, and results using the shared model code and data that was provided with the article. Why is this important? Well, it helps build trust, confirming that results are reliable and transparent. It also means that others can confidently reuse and adapt these models, with reproducibility verifying that the models are working as expected. And it can also help the original author reuse their model in other projects or just rerun their analyses in the future too, like after peer review. Reproducibility also encourages using a clear code structure and documentation, helping to reduce errors and ambiguities. Reasons that a model might not be reproducible include missing code, lost parameters, software changes, among other things. And troubleshooting this can be really time-consuming and maybe impossible if the relevant information has been lost. So the aim of this work was to generate a set of actionable recommendations to help improve reproducibility. This could help address some of the known barriers and concerns, like the skills and time required to ensure work is reproducible. So to do this, I attempted to reproduce 8 published discrete event simulation models. These are all in Python and R, and a range of different models. I evaluated the articles and repositories and documented the barriers and facilitators encountered to each of these reproductions. I pre-registered my protocol on Zenodo, and I think this is really important, as when I'm planning research like this, I find I learn a lot from the details that others share in their protocols and articles and use it to inform my own processes. I created a GitHub template, which I used to make the repositories for each of these reproductions. So each repository contained all the information from the reproductions, like the code, logs, records, and they also each generated a Quarto website. So these websites are created with Markdown and embedded code and hosted openly and freely using GitHub pages. And they're a great way of summarizing and sharing the results of the work. So here, for example, we can see the reproduced figures, tables, and also all of the logs I kept whilst doing this work. And yeah, I can just really easily share all this information as it's just a website URL. I also created a repository and Quarto site that summarizes the results from across all of the studies. So again, we sort of have all the information all pulled together here. We have things like lots of different figures. We have things that sort of sit behind the article we wrote about the work. So here, for example, this is a figure showing the time it took to reproduce each item from each paper. And then we have the version of that figure that was used in the article written up about the work. And yeah, so these figures here summarize the recommendations we've made. Things like making sure all the code that generates the tables and figures in the article is provided, or the code for the scenarios. And though this focuses specifically on healthcare discrete event simulation, lots of these lessons can also be more widely applicable as well. The work is currently in submission. We have a preprint available, which is great for sharing work before it's been published. And ongoing work on this project includes developing template models in Python and R, which implement our recommendations to help researchers adopt these practices that we are suggesting. And my work also sits alongside other efforts by my colleagues, including the STARS framework for model reusability and the STRESS framework for replicability. We're also collaborating with journals to look into their reproducibility practices, and we'll be developing training materials with HDR UK to share these practices more widely. I'd like to thank my colleagues, Tom, Alison, Nav, and Andy for their supervision, support, and involvement. And I'd also like to thank the authors of the 8 articles that were used in this research, who shared their code freely and openly, which enabled this work to take place and truly highlights the value of working openly. Thank you.